Hello and welcome to another tutorial. We are continuing with the control flow and loop statements, and now let's look at the continuous statement. So we saw the break statement, and we saw that break works for changing the flow of a loop, and we can break out of the loop or break to another loop using the labels. Similar to that is the continuous statement. The continuous statement skips the current iteration of a for, while, or do while loop. Basically, unlike break that breaks out of the entire loop, continue just tells the loop, hey, move forward, ignore the rest of the code in the body of the loop and just go to the next iteration. The unlabeled form skips to the end of the innermost loop's body and evaluates the Boolean expression, basically the condition that controls the loop. The following program continue demo steps through a string, counting the occurrences of the letter P. If the current character is not P, the continuous statement skips the rest of the loop and proceeds to the next character. If it is a P, the program increments the letter count. So we have a string here, and then int num_ps, number of p's, letter p's is 0. And obviously the maximum number of letters is the total length of the basically a string. That's why we have search me.length is the max, and we use a standard for loop. And we say that if so the string class in Java has this character at index I. If it's not equal to the character P, we're just going to continue. We're not going to increase the number of, and note that this continue is part of this if, although there is no explicit code block or scope or a pair of curly braces. I highly recommend you always explicitly define the scope of your if or for, etc. Right? Even if you have one line of statements for the body of your if, always add those pair of curly braces. And then so if the character is not P, we continue, otherwise we just increase. Now the other way to write this is to check for equality. If search me char I is equal to P, we say num_ps plus, right? And then we don't really need to explicitly use the continue, because if the condition is not met, we don't need to do anything. We already jump to the next iteration, right? But here we decide to increase the number of p's in the main flow of the for loop, and then the condition decides whether to actually do this or branch out and jump back to the condition. And note that, as I mentioned before, for the for loop we have 3 statements as the arguments of the for. When we say continue, it means the body has been executed. And if you recall from the lecture on the for loop, after the body is executed, we come back and we execute the 3rd statement. After that, we jump back, check the condition. If the condition is satisfied, we execute the body, and then again we jump back, check the 3rd condition or execute the 3rd statement, and then jump to the conditional statement, and this goes on until somehow we jump out of the for loop. All right. To see this effect more clearly, try removing the continuous statement and recompiling. Right. If we remove this, basically we just say if this condition do nothing, then we see that the numpos just increases, right? When you run the program again, the continue will be wrong, the count will be wrong, saying that it found 35 p's, which is the total length, because we decided to put this incrementing the num_ps in the main flow, which is typically not something we do, right? We always try to avoid using the explicit continue or break statements. Instead, we just try to, for example, here in this case, we can convert this to an exact match. Char equals P, and then if that meets, we just increment the P's. Note that the performance will be exactly the same because we have to always check the condition, so it doesn't really matter. A label continuous statement skips the current iteration of an outer loop marked with the given label. The following example program, continue with label demo, uses nested loops. And again, labels are only allowed for loops, and kind of they added this in the early versions of Java to again make it similar to C programming language. But really, labels are something that it's best avoided in this modern coding. It's definitely not part of the best practices. It's part of bad practices, labeling loops and trying to nest loops. Try avoid nesting loops as much as possible. It's always a code smell, let's put it that way. A label continuous statement skips the current iteration of an outer loop marked with the given label. The following example program, continue with label demo, uses nested loops to search for a substring within another string. Two nested loops are required, one to iterate over the substring and one to iterate over the string being searched. The following program, continue with label demo, uses the labeled test of continue to skip an iteration in the outer loop. Alright, so we have this string search me, we have a substring sub, boolean founded false, and then max is we want to basically search for the substring in this this search me string, right? So because we have to search exactly for this length, this number of characters, the maximum length of the for loop is the length of the original string minus the length of the substring. And then note that we're using a label here, test colon. It means we're defining a label. The compiler doesn't see it as declaring a parameter or something. If a for or some sort of loop immediately follows this label declaration, name colon. So we have we have a while loop and a for loop, and this is something that we see it kind of for the first time here, right? You can nest any type of a loop inside another loop. That's completely allowed as long as you don't have a syntax error or something. Definitely explicitly define the body of your loops. That's the best practice with a pair of curly braces. And let's see what happens. So we have the outer loop, I0, I less than max, I plus plus. We get the length of the substring. Obviously, it would have been the best practice is to cache this value because the length of the substring is not changing, right? So we could cache it and use the value both here and here. So this is a little bit, this code is less efficient in terms of like efficiency because we're just calling this method over and over again. As long as this string is small, this is fine. But always, if there is something that doesn't change in your loop, like this value of length of the substring never changes, right? So what we're doing, we can cache it outside the loop. So don't do method calls inside your loop that always return the same value because that's just inefficient. You want to cache those return values and then use the local variable. So in j equals r, in k equals 0, I'm not going to details of the logics of why these variables are designed or how it's working. I'm just showing you the for loops and basically how we are actually manually controlling the flow of the looping here using explicit continue and break statements. And again, try to avoid these as much as possible. As long as you can write your code in a way that you can avoid these continue and break statements, try to do that. While n minus minus is not equal to 0, we put a condition. If char add j plus plus is char add k plus plus, then continue. Now note that there was a better way of implement because right now we are searching, we are looking at all the characters of the substring and comparing them with the characters at the search me string, and we have to do it for all the basically for the length of the substring. But there is another method in a string called substring. It already returns a substring, right? So we didn't really need to we could call that and basically then get the entire substring at each index. The problem is that returns a new string, so each time it calls, it creates a string, whereas char add basically is just an index into the string, right? It doesn't create a new character or something. So this code is a bit more efficient in terms of not creating garbage objects, strings, but then we have more loops to do and more checks for the characters. So we have a continue here. Again, continue means skip the rest of the code and jump to this label, which means go to the next iteration of the outer loop, right? Continue means go to the next iteration, skip the rest, go to the next iteration. Break means a break out of the loop that is labeled with this label test, which means we jump completely out of this for loop, right? This for loop is labeled with test. All right, so the return statement. Obviously, return mainly applies to method, right? Any method in Java has to return something. It could be nothing, which means the return type is void, but it has to return something. And in terms of when you define or declare a method, you have to declare its return type. And again, that only applies to languages that have that are statically typed languages. At compile time, you have to tell the compiler what's going to be returned, what type of values the compiler is going to expect to see, right? The type safety of the statically typed languages is requires you to declare the type for the return value. Return means, again, more details about program execution is that any program, any machine, even a virtual machine, right, JVM, they have a stack frames, and each method call gets its own stack. And a stack is just a memory area in the memory that saves local variables of the method and other stuff related to that method, right? And then when you return basically from that method, the return value is going to, basically the stack frame of that method is going to be popped up, and then the value from the return statement is going to be pushed to the memory, right, as the return value of that method call. So you can look at the return as a branching, but again, this only applies to methods, right? You can have multiple return values in the same method call, in the same method declaration, based on maybe some if conditions, for loops, etc. But this only applies to methods. You cannot put a return, let's say, in the main, basically somewhere in the if statement, and you don't want to jump out of the method call, but if you use the return, you are guaranteed to jump out of the method call. The return statement exits from the current method, and control flow returns to where the method was invoked. And remember that in Java, the thing here is that everything has to be, every code that you execute, everything has to be inside a method call. Even your main code is in the method main, static or non-static. And for any basically method call, whether it's a static or a non-static method, you can use the return. Now obviously we don't use actually return with the main, because main is guaranteed to have a void return type, which means all you can do is say return nothing semicolon, which means just return, which you can still use to somehow break out of the main if some condition is met or not met. We will look at the example. So the return statement has two forms, one that returns the value and one that does not. It just tells the JVM that just jump out of the method without doing anything. And the only way you can do this is as if the method has the return type of the method is void. Otherwise you are obliged to return something. You cannot return nothing if the return type of the method is not void. To return a value, simply put the value or expression that calculates after the return keyword, right? Now again, this is what you return. You don't have to return a variable. You can return a statement. And what happens here is that the statement gets evaluated, and then the return value of the statement is going to be returned. What this means for this example, again, we've seen this a lot before, that the post increment or the postfix or prefix increment operators, they have a return value, and with the postfix, the return value of this expression is the new value. Let's say count was 4, and when we say, and let's say count was a local variable, right? When we say plus return plus count, count becomes 5. When we jump out of the method, the return value is 5. The count, the value of the local variable count is also 5, but then when we come back from the method call, the count variable is destroyed. The only thing that we have latched onto is the return value, right? So we just say increment the count and return the value. If we say return count plus, count was 4, the value that the count plus returns is 5. So when we jump out of the method, the return value is 5. Count was 4. That variable is destroyed because it was a local variable. So what we latch onto after the method call is returned is the value of 5, right? Just be careful that you have the freedom to write statements. Before returning from the method call, those statements will be evaluated, and result of the evaluation is the value that is returned. Obviously the types have to match. The return type of the method has to match the result of the evaluating this return statement, right? The data type of the return value must match the type of the method's declared return value. When a method is declared void, they use the form of return that does not return a value. Now actually you don't have to use this return semicolon when you are calling or you are declaring a method that has a return type void. The only time you need to do this is when you actually want to manually jump out of the method call at some point during the execution. So you don't want to execute the entire body of the method, you just want to, at some point you want to jump out and skip the rest of the body of the method call. The classes and objects section will cover everything you need to know about writing methods. All right, let's create a new class. So we already looked at the break and continue, so I'm not going to give you examples, but let's look at the return expression, for example. Let's have a main method here. So I'm going to define public static void test1, and let's invoke test1. All right. Now we want to see, so the return with some statement. Note that I'm saying a statement. Remember, a statement basically has to terminate with semicolon. So I'm going to explicitly mention it. You cannot have multiple statements. You cannot say return a statement 1 semicolon and a statement 2. This doesn't work. In other programming languages such as Python, this works. You can do this. You have to use comma and it returns a kind of a tuple structure. In Java we don't have this, so you can only return something. However, you can if you need to return multiple values. So basically in Java the convention is that if you need to return multiple values, you just combine them and wrap them in a class, wrap them in a new class definition, in a new class. And I'll show you an example how to do this, but for now let's just look at a simple example. So this has a void return value, right? So I can say sysout test1 invoked, and then I have to return. So first of all, if I want everything to be let's have another method invoked again. So if I just execute test1, everything works fine. I execute the entire body of the code, right? Test1 invoked, test1 invoked again, because I don't have to explicitly, so you don't have to explicitly mention return, right? I can say return semicolon, but that's not necessary. Note that I have to use the semicolon because, again, just like any other statement, return is a statement, so we have to terminate with semicolon. We don't need to. If I run this, nothing changes. However, I can control basically we can control the execution flow with explicit return, and that's the main idea about this return. So let's say I want some condition to be met, let's say int x, and then let's say we pass 5 here, and then we're going to we've seen the conditions, right? So if x equals 5, we're going to say that return, right? So if I don't use this return nothing, then I can never jump out of the method call if this condition is met, right? The only way to jump out of the method call if some condition is met is just return from the method, and that's the whole idea about return, right? Now if I do this, then let's see what happens. As you can see, only the first line was invoked. The second line, basically this one wasn't invoked, because again, we told the runtime, the JVM, that hey, if this condition was met, just return from the method. And JVM says, okay, you're not returning any value, which is correct because this method is supposed to not return anything, and therefore we just come back and the rest is skipped. So this means skip whatever code comes after, right? Basically I could have another statement here inside if this gets executed, but as long as anything that comes after the return, it doesn't have to be in outside the scope of the if, right? So notice what happens here. So the nice thing here is about this compilation error, and note that this is a compilation error, And the idea here is that we know that anything that comes after a return statement will never get executed. So when I'm in the scope, if this condition is met, this line is guaranteed to execute, but then we return. So this line is guaranteed to never execute, right? So never executes. And they added this to the Java compiler. I mean, they didn't have to add this, but they added this as a compilation error. And this says that unreachable code, because there is no point in having this line. That's why the compiler doesn't allow you to compile. So same with here. If I return, after the return, I put some code. This code is guaranteed to never execute, and I get a compilation error, unreachable code, right? So the Java compiler knows about this kind of stuff and refuses to compile if such things exist. Know that this is not a logical error. You can have this. The problem is that it makes your code less readable, the source code, right? Because you have returns and you see a line after that, somebody reads this and realizes that, okay, what are you doing here? They try to understand this, but then the point is that this code is never executed. You can never reach this line because you either have a return here or return here. So they decided to add this as an compilation error, unreachable code. So any code that comes after a return without any condition or anything, then it's a compilation error. You get the unreachable code. So I'm going to run this. If you put code here after the return statement, you get a compilation Java C error, which is unreachable code. So that's a compilation error, and it's good because the compiler warns you, and then you realize that that code never gets executed. So that's a good thing to have. So I hope you enjoyed this lecture. In the next lecture, we'll look at the bytecode and what happens. We've already seen that obviously in the bytecode there is also a bytecode just for returning from a method, but we will have a look at the bytecode and move on to the last part, which is the yield statement. Please stay tuned, and I'll see you in the next one.